Hello friends, welcome to lecture number 8 of matrix algebra. In the previous lecture we have seen that transpose of matrix and invertible of matrix with some example. Today we have to take some theorem and its example, how to find inverse of a matrix. Already we have studied in 11 and 12 standard how to find inverse of matrix. To find inverse of matrix by two methods. First method is row reduction method or column reduction method, and second method is by inverse formula, that is A inverse become 1 upon determinant into adjoint of A. There are two methods to find inverse of matrix. So let us start theorem. Statement that is and n cross n matrix and n cross n matrix A is invertible and n cross n matrix A is invertible if and only matrix A is row equivalent to matrix A is row equivalent to matrix IN. Matrix A is row equivalent to matrix IN. What is the IN? That is identity matrix of order n, that is n rows and n columns. This is your statement. That is any matrix A is invertible if only that matrix A is row equivalent to identity matrix. Okay. Now to state the algorithm, to find A inverse of a matrix. We have to state algorithm for A inverse of a matrix by row reduction method. How to find A inverse of a matrix by row reduction method. So your first step is given an invertible matrix, capital A. That is your first step is we have given matrix A, that is this matrix is invertible matrix. Invertible matrix means its determinant is non-zero. Second step, form augmented matrix, that is A dot I. What is your augmented matrix? Second step is we have to form an augmented matrix, that is in bracket A double dot I. A is your given matrix and on right hand side we will write down identity matrix of that order. Okay. Your third step that is apply. Your third step that is to apply elementary row operation. Third step is we have to apply elementary row operation on augmented matrix AI to obtain I into A inverse. Okay. What is your third step? We have to apply the elementary row operation on which matrix? That is augmented matrix AI. To apply elementary row operation on matrix AI to obtain, that is A double dot A inverse. That is we want to find A inverse of a given matrix. This is your algorithm or procedure to find A inverse of a matrix. Okay. Let us do example on row reduction method to find the A inverse of a matrix by row reduction method. Okay. Already we have studied studied in 11th and 12th standard how to find A inverse of a matrix. Okay. Let us have an example or equation first. Let capital A equal to 1 0 minus 2. This is your first row. Second row is minus 3 1 4, and your last third row is two minus 3 4. Okay. Let your given matrix capital A is equal to 1 0 minus 2 minus 3 1 4 2 minus 3 4. Then find A inverse. Then find A inverse by row reduction method. Then find A inverse by row reduction method. Okay. It is so easy method to find A inverse of a matrix. And on solution. Consider, your first step is consider augmented matrix A dot I. So what is the order of that given matrix? 3 cross 3, that is 3 rows and 3 columns. So your first step is consider augmented matrix AI. So your augmented matrix AI become, so A is your given matrix, that is 1 0 minus 2 minus 3 1 4 2 minus 3 4. Your augmented matrix A, and what is your I? That is identity matrix of order 3 cross 3. What is this matrix? That is 1 0 0 0 1 0 and 0 0 1. Okay. Now first step, we have to make this matrix. We have to finally make this matrix is identity matrix, and this matrix become A inverse matrix. So your first step, we have to make this matrix as identity matrix. For this identity matrix, we have to make this first entry is 1. If this 1, we have to make that below that 2 entry 0. Okay? We have to make that 2 entries 0. So how to make 0? We have to do this first 0 and this is also 0. So how to make this element 0? For that row operation, that is R2 plus 3 times R1. What is your row operation? We have to take this, we have to make this element is 0. When this element is 0, then we have to multiply first row by 3. Then we get this become plus 3, and finally take addition, minus 3 plus 3, 0. Similarly, how to make this element is 0? So what is your row operation? That is R3 minus 2 times of R1. What is your row operation? R3 minus 2 times of R1. That means your first row multiply by minus 2, then it become minus 2, and this is your plus 2. Then take this 2 minus 2, then it become 0. Okay. So then we get your first row as it is, that is 1 0 minus 2. This becomes 0 1 0 0. Okay. Your operation is R2 plus 3 times of R1. That is minus 3 plus 3 0. Right. Again, this R2 plus 3 times of 0. 3 times 0 means 0. 1 plus 0 is 1. Okay. Now 4 plus 3 into minus 2, that is minus 6. 4 minus 6, that is your minus 2. Okay. Now similar this one, that is R2 plus 3 times of R1. 0 plus 3 into 1 is 3. 0 plus 3 is 3. Okay. Next is 1 plus this 0, that is 1, and last 0 plus 0 is 0. Last third operation, R3 minus 2 times of R1, that is 2 minus 2 becomes 0. Again this minus 3 and this 0, that become your minus 3 as it is. What is your last one? That is 4 minus 2 plus 4. 4 plus 4, that become 8, right? What is this one? 0. That is minus 2 into 1, that become minus 2. This is 0 minus 0, that is 0. Last, this is 1 minus 0, become 1 as it is. Okay. Now next row operation, we have to make that second entry, that is 8 to 2 become 1. It is already 1, so we have to make that below entry 0. So how to make this entry 0? This is your minus 3. Then we have to multiply by row second by plus 3. Then plus 3 and this minus 3, we have to take addition, that becomes 0. What is your row operation? R3 plus 3 times of R2. So it become your first and second row as it is, that is 1 0 minus 2, 1 0 0, 0 1 minus 2, 3 1 0. For your last one, that is 0 plus 0 0. Again minus 3 plus 3 0. Okay. Now 8, 3 into minus 2, that is your minus 6, and 8 minus 6 become plus 2. Okay. Again this minus 2 and this 3 into 3, that is 9. Minus 2 plus 9, that is your 7. Again 0. Right. Now 0 plus 3 into 1, that is 3, and 0 plus 3 is 3. Again last finally 1 plus 0, again 1. So this is your row operation. Now last, we have to make this third element is 1. How to make 1? Divide third row by 2. Then we get, that is row R3 divided by 2. Then we get, then what will get? Your first and second row as it is, that is 1 0 minus 2, 1 0 0. Second row become 0 1 minus 2, 3 1 0. This is 3 1 0. What is your last row? We have to make divide third row by 2. Then 0 0 as it is. 2 upon 2 become 1. This is your 7 upon 2. Next entry is 3 upon 2. Last entry is 1 upon 2. Okay. Now last, we have to make this third row element is 1, and above that 2 element, we have to make that 2 element is 0. How to make this 2 element 0? So for that element, this is minus 2. If we have to multiply by third row by plus 2, then minus 2 plus 2, 0. Similarly, minus 2 plus 2, 0. So what is your row operation? That is R2 plus 2 times of R3. Next one is R1 plus 2 times of R3. So your matrix become, this is as it is. Okay. Your third row become as it is. That is your 0 0 1. This is become 7 by 2, 3 by 2. Last is 1 by 2. Okay. So what is your second row operation? R2 plus 2 times of R3. Now 0 plus 0. 0 again 1 plus 0 again 1 again minus 2 plus 2, this is become 0, right? So for this one, this is now R2 plus 2 times of R3, this 3 plus 2 times of 7 by 2, this plus 2, this 2 cancel remaining 7, and 3 plus 7 become 10, right? Again I will explain. This is R2, R2 is 3 plus 2 times of R3 is 7 by 2. This 2 and divide 2 cancel, remaining 7, and 3 plus 7 is 10. Similarly, again R2 is 1 plus 2 times of R3, 2 to cancel, 1 plus 3 is 4. Again R2 is 0. 2 times of R3, these 2 to cancel, remaining only 1. 0 plus 1 is 1. Okay. So what is your first row operation? R1 plus 2 times of R3. That is 1 plus 0 is 1. 0 plus 0 is 0. again minus 2 plus 2 is 0, right? That become we get identity matrix. You see the first one, that is R1 is 1. 1 plus 2 times of R3, that is 7 by 2, and this 2 cancel. 1 plus 7 become 8, right? Again 0 plus 2 times of R3, the 2 times of 3 by 2, that is 2 cancel, remaining 3. 0 plus 3 become 3. What is the last one? 0 plus 2 times of 1 by 2. 2 cancel, remaining 1, and 0 plus 1 become 1. So this is your identity matrix. So we get it become identity into A inverse. So this is your identity matrix, and this is your A inverse matrix. So we get A inverse become. So we get A inverse become. What is your A inverse? Your first row is 8, 3, 1. Second row is 10, 4, 1. What is your last row? That is 7 by 2, 3 by 2. Last one is 1 by 2. So what is the order of that matrix? A inverse become as it is, that is 3 by 3. When we have to find A inverse or adjoint of any matrix, then order of that matrix does not change. It become as it is, that is 3 by 3. This is your A inverse. It is so simple example. Now we can do one more example. So that was second example. It is so easy. We want to only addition, multiplication, division and subtraction must be followed. Okay. So that was next example. For same procedure. That is question number 2. Let your matrix A become. Let your A matrix become -2, -7, -9. This is your first row. Second row is 2, 5, 6, and third row is 2, 3, 1, 2, 3, 1, 2, 4. Your second row is 1, 3, 4. Okay. What is your matrix? Let matrix A become. First row is -2, -7, -9. Second row become 2, 5, 6, and third row become 1, 3, 4. So order of that matrix become 3 cross 3. Okay. Order of matrix become 3 cross 3. Then find third column. Then find third column of A inverse. We have to find third column of A inverse without computing other columns. Okay. What is your equation? We have given matrix A matrix of order 3 cross 3. We have to find third column of A inverse matrix. In the previous example, we have to find A inverse of matrix, and in this question, we have to find third column of A inverse of matrix without computing the other columns. That means we want to don't find the value of first column and second column of A inverse. We want to only find the third column of A inverse of matrix. Now for this type of example, we want to find third column. So how to find this third column? So let us write down solution. Let adjoint matrix A. Let I3 become your identity matrix. Let I3 is your identity matrix of order 3 cross 3 is become 1, 0, 0, 0, 1, 0, and third row become 0, 0, 1. So what is order of that matrix? 3 cross 3. This is your identity matrix, and this identity matrix in your column definition form become E1, E2, E3. E1 into E3 become your column vectors of identity matrix. So then your augmented matrix AI become this is your A, this is your E1, E2, E3. Okay, this is your augmented matrix become A become E1, E2, E3. Now we have to find the third column of A inverse matrix. To find third column of A inverse matrix, right? To find third column of A inverse, that is to find solution of matrix equation, So your matrix equation become Ax equal to E1, second matrix equation become Ax equal to E2, and third matrix equation become Ax equal to E3. So to find the third column of A inverse, so we have to solve only third equation, that is Ax equal to E3. If we have to find the second column of A inverse, we have to solve only second equation, that is Ax equal to E2. And if we have to find the first column of A inverse matrix, we have to solve only Ax equal to E1. So therefore, that is to find solution of Ax equal to E3 only, right? That is to find solution of Ax equal to E3 only. So now how to find the solution? So consider for this we want to consider augmented matrix AE. We have to consider the augmented matrix. In the previous example, we have to consider augmented matrix AI. Here we have to find only third column of A inverse matrix. So for this we have to consider augmented matrix A dot E3. Okay. If we have to find second column, for this consider A dot E2. And if we have to find the first column of A inverse, for that we have to consider A dot E1. So we have to find here third column. For that we have to consider augmented matrix A dot E3. So what is your E3? E3 your third column, and your A matrix become -2, -7, -9. Right? Your third column of A3 become 0, 0, 1. Okay? Your second row become 2, 5, 6, and this is your second entry, that is 0. And what is your last third row? Third row become 1, 3, 4, and your last entry become 1. Okay? This is your augmented matrix. Now, what is next procedure? We want to reduce this matrix. We want to reduce this matrix into identity matrix, and this is your A inverse matrix of third column. So for this, we want to reduce this matrix to become identity matrix. For this, we must require first entry become 1. But here is -2. Now how to make this 1? We can interchange first row and third row. Therefore we get, after interchanging the, I will erase here. Okay. So what is first proposition? That is R13. That will become, we have to interchange first and third row. So it become look like your first row become this 1, 3, 4. This become 1. Second row as it is, that is 2, 5, 6. This entry is 0. And your third row become that first row, that is -2, -7, -9, and that will become 0. Okay. Now next procedure, we have to make that one of that below 2 entry 0. We have to make this 2 entry 0. Now how to make this 2 entry 0? For this we have to make the row operation is R2 minus 2 times of R1. If this is already 2, we have to multiply here 2, and after taking subtraction, then 2 minus 2 becomes 0. Similarly, how to make this element is 0? This is minus 2. If we have to multiply by first row by plus 2, then this minus 2 and plus 2 take addition here. After taking addition, it becomes 0. What is the row operation? R3 plus 2 times of R1. So it becomes look like as your first row as it is, that is 1, 3, 4 and 1 as it is. Your second row become again this one R2 minus of 2 times of R1. This is row operation. Now 2 minus 2 become 0, right? Now this is 5 minus 2 into 3. Now minus 2 into 3, that is minus 6. Now 5 minus 6, it become minus 1. Next is 6 minus 2 into 4, that is 8. Now 6 minus 8 become minus 2. Now what is this last one? This is 0 minus 2 become minus 2. Okay? So what is third row operation? That is my R3 plus 2 times of R1. Now minus 2 and this plus 2, minus 2 plus 2, 0. Okay? Again minus 7 and this 2 into 3, that is 6. Minus 7 plus 6 become minus 1. Again this is minus 9 and 2 into 4, that is 8. Minus 9 plus 8 become minus 1. What is last one? This is 0 and 2 into 1 is 2 and 0 plus 2 become 2. Okay. Now what is next row operation? We have to make this second element of second row and second column 1. How to make 1? We have to multiply second row by minus 1. So what is row operation? That is minus R2. What is row operation? That is minus R2. So it become first row analysis, that is 1, 3, 4 and this 1 as it is. Second row becomes 0. After getting minus 1, minus become plus. This is plus 2 and this is again plus 2. And third row as it is 0, minus 1 and then become plus 2. Okay. Now next row operation. For the second row of second element, below we have to make this entry is 0. Now how to make this entry 0? We have to take addition of third row and second row. So it becomes, that is R3 plus R2. What is your row operation? R3 plus R2. After adding this addition, minus 1 plus 1 becomes 0. Right? So it becomes your first and second row as it is. That is 1, 3, 4 and this is 1 as it is. Again this is 0, 1, 2 and this is again also 2. What is the last one? R3 plus R2. Like 0 plus 0, 0. Minus 1 plus 1, 0. Right? Again minus 1 plus 2, that become plus 1. Again 2 plus 2 become 4. Okay? So we get this one. What is next procedure? We have to make the last element is 1. This is already 1. So we have to make this above element is 0. How to make this element is 0? For that, we have to take the row operation. That is R2 minus 2 times of R3. Then this become 2 minus 2 become 0. Right? So for this, we have to do the row operation. If we have to solve this matrix example, we have to must take the patience. Don't lose your patience. Okay. So what is your row operation? We have to make this element is 0. How to make this element is 0? So we have to take the row operation become R2 minus 2 times of R3. What is your row operation? R2 minus 2 times of R3. So it is so become easy. Then we get your first row as it is. This is 1, 3, 4. That become 1 as it is. Your third row also as it is. What is your third row? That is become your 0, 0, 1 and this become 4. So we have to change only second row. What is your second row? What is your row operation? That is R2 minus 2 times of R3. Again 0 minus 0, 0. So this element also 0, right? Second row operation is R2 minus 2 times of R3. It is R2 minus 2 times of R3. 1 minus 0 become, this is 1 as it is. Again 2, that is R2 minus 2 times of R3. 2 minus 2 become 0. This element is 0. What is your last element? That is R2 become value 2 minus 2 times of R3. Minus 2 times of R3. That is minus 2 into 4, that is minus 8. Now 2 minus 8 become minus 6. Okay. This value become minus 6. Okay. So what is next procedure? We have to make this first element, this element 1, and we have to make that element is 0. This is already 0. We have to make this element is 0. Now how to make this element is 0? This is 4 and here is 1. That is R1 minus 4 times of R3. What is your row operation? That is R1 minus 4 times of R3. So it become your second and third row as it is. That is 0, 1, 0. This is minus 6. Again 0, 0, 1. This 4 as it is. We have to change only first row. What is your row operation? That is R1 minus 4 times of R3. That is 1 minus 0 become 1, right? Now 3 minus 4 into 0, that is 0. 3 minus 0 become 3. What is last one? This 4 minus 4, because 4 into 1 become 4 and 4 minus 4 become 0. What is your last one? This 1 minus 4 into 4, 16, and 1 minus 16 become minus 15. Okay. This is your algebraic matrix. Now we want to do last step. We want to do this all diagonal entry 1. This 3 entry also 0. This 2 entry also 0. We want to make last this 3 entry become 0. So how to make this 3 entry 0? For that we want to take the row operation. That is R1 minus 2 times R1 minus 3 times of R2. What is row operation? That is R1 minus 3 times of R2. Because this value is 3, we have to multiply here is minus 3, and this plus 3 minus 3 become 0 after taking addition. So what is your row operation? R1 minus 3 times of R2. It is so simple operation. This 3, and you have to multiply here minus 3, it become minus 3, and after taking addition, 3 minus 3 become 0. Okay. So your matrix become your second and third row as it is. Your second and third row as it is. So second row becomes 0, 1, 0. And last element is minus 6. Again third row is 0, 0, 1 and 4. And your first row become now R1 minus 3 times of R2. That is 1 minus 0 become 1. Right. Now 3 minus 3. 3 minus 3 become 0. 1 minus 0 become 1. 3 minus 3 become 0. Right. Again 0 minus 0 become 0. Right. Now only last operation. So what this value? R1 become minus 50. Again minus 3 and minus 6. Minus minus plus 3 into 6, that is 18. Now minus 15 plus 18. Minus 15 plus 18 become plus 3. Okay. So what is this value? This value become your plus 3. So we get. So this we get will become your identity matrix, right? This is your that will become third column of A inverse. So write down therefore. So we get third column. So we get third column of A inverse is. So we get third column of A inverse is 3 minus 6 and 4. Right. This is your third column of A inverse matrix. That is, it is so simple, easy. We have to don't take here first and second column. So I guess that both examples we have to understand. Suppose if we have given another question, if we have given some matrix A matrix we have to find the first and second column of A inverse of matrix by taking the third column. For that procedure, we have to take the, if we have to find first and second column of A inverse, for that we have to take the matrix equation. For first column, we have to take matrix equation. If we want to find the first column, right? If we want to find the first column of A inverse matrix, for this we have to find that the matrix equation become A1, right? That means we have to find that A and E1, right? If we want to find the first column of A inverse matrix, for this we have to find that the matrix equation become A is equal to E1. We have to find the solution of that equation. That means we have to consider the argument matrix A dot E1. And if we have to find the second column, if we have to find the second column of A inverse of matrix, for this we have to consider the matrix equation become A is equal to E2. We want to find the second column of A inverse. For that we have to consider matrix equation become A is equal to E2. That means we have to consider the argument matrix A dot E2, then solve the same procedure for that example. I hope all part you have understood. So remaining part we have to study in next lecture. Thank you.